Interferences in atomic absorption spectroscopy are confined to the phenomena that affects the number of atoms in the flame. The different kind of interferences that are found in atomic absorption spectroscopy are as follows. First, spectral interferences. Spectral interferences may be caused by overlapping of absorptions of interfering species with the analytical absorption. The interfering radiation may be an emission line of another element, radical, or molecule, or it may be unresolved band spectra or general background radiation from the flame or solvent, etc. Examples of such interference are overlapping in manganese triplet, potassium doublet. If two lines are as close as, for example, vanadium at 308.211 nanometer and aluminium at 308.215 nanometer, there may be an interference which can be eliminated by selecting a line for aluminium at 309.270 nanometer. The presence of combustion products can also be mitigated by using a blank containing the same chemical products, and it can be easily corrected with a single beam model. The spectral interference is also caused by scattering byproducts of atomization containing refractory oxides. This can be avoided by variation of temperature and fuel to oxidant ratio in the flame. We can also employ a background correction by continuous source correction method and also Zeeman effect correction method. Next type of interferences are chemical interferences. Chemical interferences in atomic absorption spectroscopy is due to the formation of compounds of low volatility, dissociation equilibria, and ionization in flames, etc. Usually, anions form compounds of low volatility and reduce the rate of atomization. Cations can also cause interference. For example, aluminium, if present as an impurity in magnesium, reduces atomization of the latter element. We can use high temperature flames or releasing agents to eliminate this interference. Ionization interferences are another kind of interferences found in atomic absorption spectroscopy. Ionization in flames causes serious interferences, especially with flames involving oxygen and nitrous oxides. For example, a loss in spectrochemical sensitivity results due to the splitting of a free metal atom into a positive ion and an electron. The ionization interference is mainly caused by alkali metals which require low energy for ionization. In case of alkali metals like sodium, increased temperature causes an increase in population of excited atoms. Counteracting this effect is a decrease in concentration of atoms due to ionization. Thus, lower excitation temperatures are preferred for alkali metals. The degree of ionization will also be influenced by the presence of other ionizable metals in the flame. Dissociation of metal compounds is another type of interference in atomic absorption spectroscopy. This interference is due to incomplete dissociation or formation of refractory compounds. When metals like aluminium and vanadium are aspirated into the flame, extremely stable refractory oxides are obtained. Such interferences can easily be eliminated by addition of a small amount of lanthanum as it binds aluminium and chromium, silicon, and leaves strontium free in the analysis of strontium. Viscosity also makes a difference. Carbon forms refractory compounds. A coating of graphite with vitreous carbon avoids carbide formation. This also prevents the penetration of samples into porous graphite. Interference due to excessive background emission can be compensated by the use of hydrogen or deuterium lamp. Effect of solvent. In general, metals in aqueous solution yield lower absorbance readings than the same concentration of such metals when present in an organic solvent. Because the metal is more difficult to atomize from an aqueous solution than from an organic solution.